We need to find out the nth term of the following arithmetico-geometric series. Let us begin. Now here we have a series whose first term is 1. Then we have the next term 3 over 2, followed by 5 over 4 and 7 over 8. And this continue. Our goal will be to find out its nth term. However, this is not a arithmetic series, neither it is a geometric series. So that means if it is not an arithmetic series, we cannot define the common difference, and if it is not a geometric series, then we cannot also define its common ratio. However, this particular series is composed of both the arithmetic as well as the geometric sequence. Now what we'll do, we're going to try to find out the arithmetic progression and the geometric progression. For this, we have to rewrite each of the terms. So the first term can be expressed as 1 multiplied with itself. Then we go to the next term, which is 3, and we're going to multiply it with -1/2. Coming to the third term, we have 5 multiplied to, so here we have 1 over 4, but we're going to express it as 1 over 2 squared. Added to, then we have 7. 7 will get multiplied to -1 over 2 cubed. And this is going to continue. Now here, if we consider a 1, 3, 5, and 7, then this particular sequence is going to be in arithmetic progression. So let's verify that. So here, 1, 3, 5, 7, and so on are in arithmetic progression. It's true. It's going to be in arithmetic progression because the first term a, that's going to be equals to 1, that's fixed here. Then the common difference, which can be obtained by taking any term in the sequence and subtracting the previous term from it. So let's say if we take the third term 5 and from it subtract the second term 3, so that's going to give us 2. Similarly, we can find out 7 minus 5, that's 2 as well. Yeah, the common difference is going to be 2. So that means our given sequence is indeed in arithmetic progression, and we can define its nth term. Then the nth term an, which is given by the formula a added to n minus 1 times the common difference d. So when you substitute all of these values here, we're going to get 2n minus 1. Now that's going to be the nth term of the arithmetic progression. And we're going to consider the terms where the 1, -1/2, positive 1 over 2 squared, then -1 over 2 cubed, and so on. So we're saying that this sequence is in geometric progression. Now, if there's geometric progression, it would mean that it's going to have a first term, so that's going to be 1 in our case, and it's going to have a common ratio. Now, the common ratio can be obtained by dividing any term with the previous term. So if we take the second term, which is -1/2, and divide it by the first term, so that should give us -1/2. We can verify that if we take the third term, which is 1 over 2 squared, and divide it by the second term, that is -1/2, it's also going to give us the same common ratio, -1/2. So that means the sequence is indeed in geometric progression. Now we can define its nth term. Then the nth term, which is given by the formula a times r raised to the power of n minus 1. So in our case, we're going to get 1 over -2 raised to the power of n minus 1. However, we can pull out the negative sign, so that's going to give us -1 raised to the power of n minus 1 multiplied to 1 over 2 raised to the power of n minus 1. So that's the nth term of the geometric sequence. Now that we have the nth term of both the arithmetic sequence as well as the geometric sequence, we are ready to find out the nth term of the arithmetico-geometric series. So here we consider the nth term of the arithmetic progression, so that's given by 2n minus 1, and to it we're going to multiply the nth term of the geometric sequence, so that's -1 raised to the power of n minus 1 multiplied to 1 over 2 raised to the power of n minus 1. So this is going to be the nth term of the arithmetico-geometric series. We can verify this. So let us consider n to be equals to 4. So that means we want to find out the fourth term of the series. So here we have 2 times 4, so we have 2 times 4 minus 1. This will get multiplied to -1 raised to the power of 4 minus 1 multiplied to 1 over 2 raised to the power of 4 minus 1. Now 2 times 4, that's 16. 2 times 4 is 8. 8 minus 1, that's 7. So we have 7 multiplied to -1 raised to the power of 3. So 3 being an odd number, so we're going to get -1 divided by 2 raised to the power of 3, and this is going to give us -7 over 8, which is indeed the fourth term of the series.